So how many of you really want to be me right now and follow that? Okay, so I'm going to talk about exports, export processing in the ocean from remote sensing. It is a NASA field campaign that is done in partnership with the National Science Foundation. So just, I don't have anything blowing up. I feel so inadequate at this moment. The goal of exports is to predict the export fate and carbon cycle impacts of ocean net primary production from satellite data. It builds on decades of NASA building techniques to understand how to quantify net primary production from space and giving it a biogeochemical impact. So the focus is on quantifying export pathways and NPP phase over a range of states. We emphasize a predictive understanding. We want to help improve how models work, both diagnostic models in present states, but also models into predicting future states. And it leverages advances in all these sort of things that have happened over the last decade. So we're going to focus on the pathways. How does sinking, I'm not going to use anything besides my finger, how does sinking work, and how do the different sinking pathways work? What is the role of diel-vertical migration? What is the role of physical transport in this problem? So so how does it work? This is very much a NASA-centric thing. We have science questions that we have to ask. We have science that we ask and have to answer. And how we answer them is how the field program is developed. So the first question is, how do upper ocean ecosystems characteristics determine the vertical transfer of organic matter from the surface ocean? The second is, what controls the efficiency of that transfer below the euphotic zone? And then how do we use that to improve our ability to do models? So at the 675 kilometer height, view of the thing, we have two field programs. We have conducted a program at Station P for 27 days on site, and I'll talk about that a lot today. We have one coming up in the spring of 2020 and in the North Atlantic, nominally 50 north, 30 west. I got that backwards. That was a Freudian slip. I went 30 north because I'm sailing. So with all of this, and along with some data mining grants that were funded, we hope to get enough ecosystem states that we can start to build and test real models. So kind of where we are on a timeline, there are a series. So where are we today? We're about right here. We're in the middle of 2019 or so. We have NASA funded a series of data mining and modeling modeling proposals before us with the help the planning exercise. The phase one field program started sometime in late 2017. We're in the middle of that. That will end somewhere around here, someplace. The first field program is shown up there with both the autonomous vehicles and then the stars are the major field times. There will be a phase two, and I'll talk a little bit about that. There's plans for a phase two, I should say, and I'll talk about that. So it's not me. I'm only the chief. I'm the chief goat herder. There are a whole bunch of PIs in phase one. Many of them are here, by the way, and they have a whole range of expertise. Everything you can imagine, everything that anybody can do, everything from genomics to sub-mesoscale turbulence to geochemistry. It's all it's a complicated system, and we had to develop plans to deal with that. So I'm going to talk a little bit about. I'm going to talk mostly about what we did in the North Pacific. Our timeline is we had a field program that went out in August. We had a field program, and then was followed up by the Canadian Line P reoccupying our site. The observational plan was two ships, one doing process work, one doing surveying work around it. The Roger Revelle was the process ship, the Sally Ride was the other, and a series of both following a water following float with the sea glider, making transects around that. We leveraged the existence of the PMEL air-sea interaction mooring as well as the OOI assets that were at Station P. There was a lot of effort was done to make certain that we can ground truth all the different vehicles, both biological floats, the Siegel, and a bunch of that by doing direct intercomparisons with the ship. So this is just showing, before we were out there, the Sea Glider was deployed on an OI trip. The two ships came to the site, and which one's which? This color is Roger Revelle, and we proceeded to do these 3 8-day sort of epics or epochs, or they were epic epochs, or all those things work. And so we continue this. There's, as you can see, there's lots of activity going on. In the interest of time, I'm going to move forward if I can. The Sea Glider measured a bunch of things. One of which is chlorophyll fluorescence. You can see that basically we were there, and about right there about right here we got out, and then of course the ocean bloomed, but that's another issue. So what did the ships do? With the process ship was focusing on rates, on taxa. Everything had optics because we had to link everything back to PACE and all the future missions. A big focus was getting at the export pathways and those things. This is what and so with all those activities we built. This is proposed of what we did. And so for each epoch, we broke things down in sort of these hour sequences about, when we were going to run the mocknesses, when we were going to deploy the sediment traps, the marine snow catchers, those sort of things. The idea was to develop an integrated data set for each of these 8-day windows. This is just what one set would look like. What do I want to say? This is what we ended up doing. And we've got a pretty good sense as to, so there's a lot of activities going on. These are deployments of sediment traps, a wire walker array, a marine snow catcher. I think the Marine Text script said it's not like we haven't done these things before, we've just never done them all at the same time. So the survey ship also did a lot of optics on it. It did a lot of the it was focused a lot on the intercomparisons with the glider and float data and the bioargo floats. It also did. It also deployed where the large volume pumps were deployed, and the 234 thorium group was there. So. What do I want to say? So the surveys here kind of this just describes what the level of the sampling was. We are what? We're 7 months? No, we're 10 months out in the field. We're still in the process of getting data sets together from that. So in May of this year, we had our science team meeting. I wish I had my tri-horn hat at the moment. Our focus there, so one of the things that we did when we started is, before we sailed, we sat down everybody and said, okay, what measurement are you going to make? We need a 2-page write-up on the protocols of each measurement, and we need a good understanding so we could put that together. So a lot of the data management was done before we sailed. We already had a pretty good sense of what was sampled. So here we talked a lot about synthesis groups. Where are we? Where is everybody? And we kind of effectively used peer pressure to get people to work together. So the working groups were on sort of export pathways, food webs, biogeochemical budgets, optics and biogeochemistry, and trying to elucidate kind of space and time variations in the data set. So I'm going to go through real quickly stuff that I had access to from the science team meeting and just kind of show the scale of things that went on. If your data's here and I say something wrong, I apologize. If your data's not here, I apologize. I just apologize. Okay. So just to start, just to kind of put things through, in terms of, we had on both ships what's the damn thing called? IFCB, imaging flow cytobots. There we go. On both ships, this is from Colin Ressler and Hadi Sosik. showing the carbon in diatoms and dinoflagellates from the ship, from the survey ship. We measured rates all sorts of different ways. This is an example from Kim Halsey's group of what the CFC14 is. And then, Xiaodong Zhang at Dallas, University of South Mississippi has put, his group has put together he's working on the particle size distribution, going from literally nanoparticle size distributions out to centimeters. And so we're working on all sorts of, we're just into the data sets now. We link things to optics. That didn't come out well, but we did measure the reflected spectra. So for each day and each measurement, we have a link to what a satellite would see. And so with this is hyperspectral reflectance, so we can relate our measurements to pace. On the lower panel, this is data from Emmanuel and Lee Karpas's work, showing just how optical variability. The yellow is a measurement of the light, and it's showing all these measurements of what the slopes of different optical properties, the spectral slopes of different optical properties are, what the phytoplankton carbon chlorophyll distribution look like, how the median cell walls, how cell volumes changed by looking at particle scattering. We had a full program looking at secondary production. Here's some of work from Amy and Debbie showing day-night differences in mock nest toes, showing a migration of salps that are going on. I guess those are salps, right? Okay, good. I wouldn't know. And then this is some of Amy's work looking at the actual what demands that they have and linking this to acoustic data sets that we have in the field. And then Craig Carlson and Dennis Hansel's group is looking at DSC dynamics and microbial things. So we have both so this will let us get at the migrant fluxes. This will let us get at some of the microbial fluxes that are going on. And we measured export. And so this is from Ken and Claudia and Laura's group, looking at the vertical carbon fluxes that are measured on average from the 234 thorium technique. And Colleen Durkin and Melissa Omond and Megha Stapa have here just ideas of what the different components, and all these things are unreadable, but it's, so these are different components of things found in gel traps that they looked at. That top image there is a time-lapse movie of what a gel trap looks like in situ. So it's a trap, and you're looking up through it. When it's light, it's daytime. When it's not light, it's dark time. And then we have a lot, we'll look at variability in time, both looking at things from our autonomous vehicles up here in the top panel. Andrea Fossbender's group is looking at BioArgo data sets. And lots of groups are now trying to put their stuff in order. This is an example from Scott Gifford and Adrian Marchetti, where they're looking at, in this way, this is bacterial composition, and then looking at how these things change in time. So for what seemed to be the most boring place in the world, we seem to have lots of variability going on, which is going to be kind of cool once we get all these stories together. So, fonts went nuts. Oh well. That was the Pacific. We are making our plans for the North Atlantic now. The idea is to find a contrasting end member to what was supposed to be the boringest place on Earth. What we want are bigger signals in biomass. We want to focus on assessing the post-bloom carbon cycle fates. And so looking a little bit later in that year, we want to have high mesoscale and sub-mesoscale energy so we can look at things. There's stuff that got caught off the bottom of this. Now I got to remember what it is. We're working on the schedule now for this. We have a request in for 2 days of the Atlantis and Armstrong for 28 days on station to go to 50 north, 30 west. I forget what's on the bottom of these. There are 2 more bullets here that I'm going to have to fabricate out of my mind. What? Yeah. The schedule needs to get kind of worked out shortly. The good thing is that Willows is able to figure out how to put two ships in the same place at the same time, leave them in the same port. That was a minor miracle. The other thing that's going on is that the Woods Hole Oceanographic Institution's Twilight Zone group is going to deploy a third ship to there, so it'll be about a 10-day rendezvous with us. We'll be looking at higher trophic level things. That's all I have to say about that. Everything's in the planning stage. I hate this. I hate things being in a planning stage. Okay, now for something completely different. Sorry, indulge me for a sec. Anybody know what this is? Anybody know what this is? So this thing's 25 feet high and 60 feet across. How many people are sitting at the end of the square? Okay, so you go to the bus station, you go up to the top of the hill, and right there is Highfield Hall. This is a remarkable structure that this guy Patrick Doherty has made out of Willows. It's an art installation. It got built this last week. It's phenomenal. Anyways, if you're bored and you have nothing else better to do, this is a good thing. So with that, I'll shut up. And I'm around all week. You want this?